Question number 2. This question is about the halogens which belong to group number 7. Question number 2.1. AO1 question. Which group in the periodic table is known as halogens? If we use a periodic table, the group number 7 elements are called halogens. Two point two. 2.2 is an AO2 question, and this question is from group 7 elements and covalent bonding. A fluorine atom has 7 electrons in the outer shell. Figure number 8 shows the part of a dot and cross diagram to represent a molecule of fluorine, F2. Complete the dot and cross diagram. You should show only the electrons in the outermost shell. Fluorine has 7 electrons: 1, 2, 3, 4, 5, 6, and 7. It needs one more electron to make 8, so it will become stable like noble gases. If you look into our figure number 8, we need dot and cross. We have to complete our diagram. Here both are fluorine, so no one is going to lose the electron. So only the option left behind is they are going to share the electron. So each one has shortage of one electron, so they will share one electron with each other. If we're going to use this thing, the dot and cross diagram, so this fluorine is going to share one electron, and this fluorine is going to share one electron. So as a result, let's see how many electrons are there. 1, 2, 3, 4, 5, 6, 7, and 8. Similarly, for this fluorine, it has 1, 2, 3, 4, 5, 6, 7, and 8. Let's see the structure again. After sharing the electron with each other, we will see how many electrons are there altogether. 1, 2, the shared electrons, 3, 4, 5, 6, 7, and 8. Let's see this atom of fluorine. 1, 2, 3, 4, 5, 6, 7, and 8. So this is dot and cross diagram, which is actually related to covalent bonding. And here we can see that each one is sharing one electron with each other. After sharing the electron, everyone has 8 electrons in the outermost shell, and they are stable and they look like noble gases. If you go back in the next question, 2.3, chlorine reacts with potassium bromide solution. Complete the word equation. Is an AO2 question. Students need to apply their knowledge. This question is coming from group 7 elements and structure of an atom. In the chemical reaction, chlorine is displacing the bromine from the potassium bromide solution. The reason is chlorine is more reactive than bromine. In this chemical reaction, this chlorine will displace the bromide and make a chemical reaction with potassium. So we have here bromine, a bromine, and we have the chemical compound here, which is potassium chloride. Students make very common mistake here. Here, instead of writing bromine, they're still writing word bromide. So this is the mistake, a common mistake that students are making, and they are losing 1 mark. 2.4, which is an AO1 question. What type of the reaction happens when chlorine reacts with potassium bromide solution? Chlorine is more reactive than bromine, and if you go down the group 7 elements, the reactivity decreases as you go down the group 7. So chlorine is more reactive than bromine, so it will displace the bromine from potassium bromide solution. So it is a displacement reaction. Question number 2.5, complete the sentence, is an AO2 question. Choose the answer from the box. It is from group 7 element. Chlorine is more reactive than bromine. This is because chlorine gains dash more easily. Now, the options are given here. So it is a chemical reaction. So protons are not taking part. The neutrons are not taking part in the chemical reaction. Chlorine is not losing or gaining any atom. So they are taking the electron. Student must remember that in a chemical reaction, electrons are taking part. Our next question is again an AO2 question, 2.6. The key information is already highlighted here. How does the size of chlorine atom compare with the size of bromine atom? Complete the sentence. Choose the answer from the box. If you look back in our group 7 elements, if you go down the group, the size of the atom is increasing. It belongs to period number 3. Chlorine belongs to period number 3, whereas it belongs to period number 4. Period number 3 means that it has 3 shells, whereas period number 4 means there are 4 shells. If you look in our question, a chlorine atom is dash a bromine atom. As chlorine belongs to period number 3, so it has 3 shells. Bromine has 4 shells. Therefore, chlorine is smaller than bromine. A chlorine atom is smaller than a bromine atom. Question number 2.7, which is an AO2 question. Give a reason for your answer to question number 2.6. This question is coming from periodic table and the group number 7 element. We already mentioned that chlorine belongs to period number 3. We already mentioned chlorine belongs to period number 3 and bromine belongs to period number 4. So chlorine has less shells as compared to bromine. Therefore, it is very easy for chlorine to take the electrons. So the answer is chlorine has less shells than bromine. Chlorine has less shells than bromine. Question number 2.8, which is an AO2 question, and this question is from the concept of atom, elements and compounds, and group 7 element. A student make a chemical reaction. He needs to balance the chemical reaction when fluorine and chlorine reacts and they form ClF3. If you look here in our balance equation, this information is missing here. How many moles of fluorines are used? We know that Cl2 is balanced with 2Cl. These two belongs to both chlorine and both for fluorine. If you look here for the fluorine, when this 2 belongs to this fluorine, so fluorine is already 3, so you're going to multiply 2 times 3 is equal to 6. Whereas 2 is present here, to make 6, we need 3 moles of fluorine here, because when they're going to multiply 3 times 2, we will get 6 on the left side. The student needs to compare the number of moles of chlorine and fluorine on both sides. Question number 2.9, which is a combination of AO1 question and AO2 question. Explain why fluorine is a gas at the room temperature. Use the following words in your answer. The student should include these words in the answer: energy, forces, molecules, and weak. So group 7 elements. The question is from group 7 elements. Properties of the small molecules also. We see the fluorine molecule, which is F2. A single covalent bond is present between fluorine and fluorine. If you look here, this is one fluorine molecule, this is another fluorine molecule, this is another fluorine molecule. These green lines are showing the covalent bond present between fluorine and fluorine atoms. These dotted lines between the molecules are showing the intermolecular forces present between the molecules of fluorine. These intermolecular forces between the neighboring molecules are very weak. Therefore, it needs a very little energy to break these intermolecular forces present between the molecules. Whereas these green lines are very strong. Students usually make the mistake here. When they are using the information, they are mentioning to break these bonds present between the fluorine atoms. When we provide the energy is used to break these intermolecular forces. The energy is not used to break these bonds. So the model answer is there are weak intermolecular forces between the fluorine molecules, which are given here. Therefore, it needs very little energy to break these intermolecular forces between the molecules. So these forces can be broken easily by providing the very little energy. Therefore, the fluorine is gas at the room temperature.